Hello everyone, this slide shows about concrete presented by Ahmed Afifi, Farah Shaheen, Mohamed Elboraey, Osman, Nour ElMahdy and Omar Othman. What is concrete? Concrete is a heavy, rough building material made from a mixture of broken stone, gravel, sand, cement and water that can be spread or poured as a binding material. Concrete is an essential material with a worldwide estimated consumption between 21 and 31 billion tons of concrete in 2006. Concrete is the second most consumed substance on earth after water. History of concrete. Concrete as we know it today is the product of an implemented research that started during the Greek civilization. As a matter of fact, they mixed crushed limestone with water and that mixture drilled with air contact due to chemical reaction between carbon dioxide and limestone. However, its use as a limited to facades as it needs air to dry. Later on, Romans developed the mixture by adding crushed fired brick, inventing the first mixture that solidified due to chemical reaction with water. Unfortunately, the recipe of the Roman concrete was lost. It was only in 1818 that a French engineer named Louis Vicat created a new mixture while trying to figure out the secret of the Roman concrete. He mixed clay and limestone and fired them together instead of separately like they used to create a new hydraulic mixture. Portland cement. Portland cement is a mixture of processed limestone, shales and clay. Egypt is the Arab region's largest cement producer and it exports cement at almost half the price charged in most parts of the world. It is the fourth largest market in the Mediterranean rim in terms of grey cement and white cement consumption. Egypt is also expected to be one of the top 5 global exporters of cement in the next few years. Types of concrete in Egypt: plain concrete, reinforced concrete, precast concrete, pre-stressed concrete, high-strength concrete, self-compacting concrete, lightweight concrete, heavyweight concrete, and sulfur concrete. Plain concrete. The term plain concrete is used to describe any concrete mass used without any strengthening material. The physical properties of plain concrete are very similar to stone and include the ability to withstand great pressure. Reinforced concrete. Reinforced concrete is made to sustain tension. Steel bars are added in the areas prone to tension so that concrete does not break when exposed to tension. When concrete is over-reinforced, it breaks all of a sudden without showing any signals such as cracks. The disadvantages of reinforced concrete is that it has low tensile strength, about 1/10 of its compressive strength. It needs mixing, casting and curing, all of which affect the final strength of concrete. The cost of the forms used to cast concrete placed in the form. It has a low compressive strength as compared to steel. The ratio is about 1:10 depending on the material, which leads to a large section in columns of multi-story building. Cracks develop in concrete due to shrinkage and applications of live loads. Precast concrete enables faster program timings, not affected by weather or labor shortages. It improves constructability. Early enclosure of dry envelope enables follow-on trades to start sooner. Produces a high standard of workmanship in factory conditions, reduces potential for accidents, addresses on-site skill shortage. Has a high quality finish that can be left exposed. Concrete thermal properties can be exploited in low energy buildings. In precast concrete, it keeps water out, it prevents air leakage, it controls light, controls radiation of heat, controls reduction of heat, and controls sound. The disadvantages of precast concrete is have very heavy members, cambers in beams and slabs, very small margin of error, connections may be difficult, somewhat limited buildings design flexibility. Because panel size is limited, precast concrete cannot be used for two-way structural system. Economics of scale demand regularly shaped buildings. Need for repetition of forms will affect building design. Joint between panels are often expensive and complicated. Skilled workmanship is required in the application of panel on site. Cranes are required to lift panels. Pre-stressed concrete. Concrete remains uncracked. Reduction of steel corrosion. Increases durability, good for pressure vessels, high span to depth ratio, less dead load and more economical. The disadvantages of precast concrete: more expensive in materials, fabrication and delivery, heavy precast member require large cranes, limited design flexibility, small margin for errors, more complicated design. High strength concrete: high early strength, high modulus of elasticity, it has a high abrasion resistance, high durability and long life in severe environment, it has low permeability and diffusion, and low resistance to chemical attack. The uses of high strength concrete is used in high-rise buildings, in bridges and in offshore structures. There are two primary disadvantages of using high performance concrete. The first is that the cost is higher than the normal concrete, often prohibitively so. The other disadvantage is the relatively small amount of long-term research on how it holds up over time and in certain conditions. Self-compacting concrete: it has self-compactability, avoidance of bleeding and segregation, low shrinkage, low permeability, strength are needed, used in narrow places where no vibrators can be placed. Lightweight concrete: has fire resistance, high strength to weight ratio, energy efficient, sustainable design, greater comfort and safety for occupants. The disadvantages of lightweight concrete is that it's very sensitive with water content in the mixtures, difficult to place and finish because of the porosity and angularity of the aggregates. In some mixes, the cement mortar may separate the aggregate and float towards the surface. Mixing time is longer than conventional concrete to assure proper mixing. Heavyweight concrete: it has a high density which is greater than 26,000 kg per meter cube. Its primary use is in radiation shielding, either in nuclear power plants or in radiation therapy units. It can also be used as ballast in foreshore locations such as pipelines. Egypt is one of the greatest cement producers all over the world and the leading country in the Middle East, Africa and Arabian region, with a total production capacity of 50 million tons of cement. Some of the examples of the manufacturers are Italia Cement, placed in Cairo. It has 5 plants and 3 business units: Suez Cement Plant, Attamiyah Cement Plant, Tora Cement Plant, Helwan Cement Plant, and the White Plant in El Minya. Egyptian Cement Company recently became Lafarge Cement Egypt, with a total production capacity of about 10 million tons of cement, coming from 5 lines designed and manufactured by Polysius France, arranged at the second plant all over the world on the cement production. Sinai White Cement Portland, Masr Bani Suef, Masr Ina, Cemex, Al Amriya Cement Company, Titan Cement Company with 2 plants, one located in Alexandria and the other in Bani Suef, Al Arabiya for cement, Al Swedi for cement, South Valley for cement, the National Cement Company and the Arabian Cement Company are all examples of companies that produce cement. However, the best commonly used cement, based on what all engineers would prefer to use, is Sinai cement, which has an average price of 35 Egyptian pounds per sack, and the common sack in Egypt weighs about 50 kilos. Manufacturing process. This picture describes the control room. It is where the entire project is controlled and the ratio of the mixture is determined according to the user needs. This picture would depict the sand aggregate, how it's stored, and it's stored under sheds to avoid being damped or affected by rainwater. This picture shows how aggregates are moved around the site using a railing. This picture shows how the cement is stored one above the other and stored in separate piles. This picture shows the cement and admixture tubes, a concrete mixer, concrete installation procedure, site work. Before concrete can be placed, the site needs to be prepared. The area needs to be cleared and cleaned. All grass, rocks, trees, shrubs and all concrete needs to be removed, leaving only a flat soil. Forming. Once the subbase is prepared, forms can be set. Concrete forms are made from wood, metal or plastic. For most residential concrete projects, wood forms will be used, held in place with the metal or wood stacks. The forms are attached to the stacks with screws or special nails to allow for easy removal of the forms after concrete has been poured. Special forms and forming methods are employed for stairs and walls. Placement. The contractor has ordered a concrete mix that meets the requirement of the slab being placed. The concrete will arrive in a ready-mix concrete truck. The drum on the back of the truck will be spinning slowly to keep the concrete inside from settling and getting hard. The ready-mix trucks may be able to pull up the site and pour right into the form. If the site is on the other side of the house or building, the ready-mix trucks may pour into a concrete pump to get the wet concrete to the site. The contractor and the crew will pour wet concrete into the form until they are fully at the top edge. While the wet concrete is being poured, contractors will be using shovels and racks to move the concrete to make sure there is no voids or air pockets. Early finishing. Once wet concrete has been placed into the form, a large metal or wood board is used to screed the top of the concrete. The screeding process helps compact and consolidate the concrete and begin smoothing and leveling the top of the concrete. Rolling. The concrete will be left to rest until the surface begins to firm up. Once firm, steel trolling is performed to create a smooth, hard and uniform finish across the concrete surface. Finish. Once all the trolling is complete, the final finish can be applied to the concrete. The most basic type of finish is known as the broom finish. A special broom is pulled across the concrete surface, creating a rough textured surface. There are samples of the concrete. These are the list of references that were used to prepare this presentation. Thank you for listening.